all of you are doing well. My name is Riya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Level. So in this video, after having taken a look in great detail about what normalization is, why do we really need normalization, and what are the disadvantages and the problems we encounter without using normalization, is all what we've already discussed. If you have not watched that video, I would highly recommend to take a look at that video once before coming to this one. Now, since we have gained all that knowledge, now would be a good time to actually introduce some of the advantages and disadvantages of normalization. Okay, so let's quickly take a look. One of the first advantages of using normalization is that normalization helps to minimize data redundancy. That is what all we have been talking about for so long. Second, it helps to create a better and overall greater database organization, right? The organization is organized in a far better way when we are using normalization. The third point is about data consistency. When data is organized using normalization rules, then we can pretty much ensure that all of the data is consistent, and we can kind of make sure that no inconsistent data is present in our databases. Next, we talk about the fact that with normalization, we come across a more flexible database design as well, where it is more easier to add entities and add attributes to that database design. And the last point is that it enforces relational integrity. Okay, so this point of relational integrity is we have talked about in the relational model videos. So if you've not checked that out, you can check that out as well. But understand that normalization enforces the concept of relational integrity. Okay. All right. Now we'll touch briefly upon what are the disadvantages of normalization. Okay, the first one being that you cannot start building the database before knowing what the user needs, correct? Now, the thing about normalization is you cannot just start and making tables and then introduce normalization to it, right? In order to make sure that the databases are fully normalized, you first have to understand the user expectations. So till the time the user does not communicate their own expectations of what kind of database they want, normalization cannot be introduced to the process of organizing databases. Okay, that's one disadvantage. The second disadvantage is the performance degrades when normalizing the relations, when we start normalizing the relations to higher normal forms. So I told you in the start that normalization is not a one-step process. It's a multi-step process. First you do the first 2 steps, then 3 steps, and 4th step and 5th step. So the idea behind this point is, by the moment you reach the 4th and the 5th normal forms, the performance of the database actually starts degrading a little bit. So you have to maintain a good balance over here of how much normalization are you really introducing. How many steps are you really doing for the normalization process? The third point being that it's actually time consuming. If you will really, when we will start taking a look at what actually normalization is, you will realize that normalization is a time consuming process. It's difficult to do, right? And it's actually like to take the normalization to, like I told you, 4th and 5th normal form, it's not easier. It takes time, and it's a little complex process as well. And the last point is careless decomposition may lead to a bad database design, leading to serious problems. So I told you in the start when we were discussing the definition of normalization that in this process we start decomposing the tables, right, in order to introduce good structure. But if the decomposition process is not done carefully, and if it's a careless process, it actually leads to a very bad database design, and it can lead to a lot of serious problems. Okay, so that's what the overall concept is, that if you do the decomposition process carelessly, it can actually, instead of improving, can lead to a bad database design, which leads to more serious problems. Okay, all right. So now what we'll do is we'll actually start with our journey to introduce what are the multi-steps that we have to do. Okay, and what exactly is the multi-step process to achieve normalization. The first one is the first normal form, we call it. Then we introduce the second normal form. Then we introduce the third normal form. Then it is known as BCNF normal form, Boyce Codd normal form. And then we have the fourth normal form. Okay, there's fifth normal form also, but I think for the scope of this syllabus, I think just understanding till fourth normal form is more than enough. Okay, all right. So we'll start with the very first normal form, which is 1NF normal form. So the rules defined in one normal form in such a way are that first, a relationship or relation as in the table will be in 1NF if it contains an atomic value. Okay, by atomic value it means that you cannot hold, it says over here that an attribute cannot hold multiple values. You remember the example where we took about for in the ER modeling process, where we talked about multi-valued attribute, for example a phone number. Now for a student who is enrolled in a 4th, he or she may have multiple phone numbers, right? So one normal form says that it prohibits having multi-valued attributes. Okay, here it says first normal form disallows multi-valued attributes. Okay, that means one attribute will have just one value. It must only hold single valued attribute. Okay, along with that, you cannot hold composite attributes as well. Now, do you guys remember that we also did in the concept of ER modeling, we talked about composite attributes, right? For example, an address. An address is a composite attribute which is an aggregation of single attributes such as street number, pin code, city, etc. So one normal form does not allow multi-valued attributes. It does not allow composite attributes and any of their combinations. Okay. For example, you will see that in this employee table over here, this is not in 1NF form or one normal form because of the attribute employee phone. Right, here you can see for John and Sam there are multi-valued attributes present, right? For the employee phone attribute, the values are multiple. For John there are 2 phone numbers, for Sam there are 2 phone numbers. Now this kind of a structure is prohibited if you want to make sure that the very first step of normalization is achieved. Okay, so this table right now is not in one normal form. The correct way to do this is the decomposition of the employee table into 1NF that has been shown over here. Okay, here you can see that employee ID is there, and here everything has been segregated into different parts now. So now here for John, who has 2 phone numbers, now it actually has become 2 records, okay, or 2 different rows in the table. Now this table is considered to be in one normal form. Okay, so that's what you need to keep in mind while designing the databases. Okay, let's take one more example. I'll show you so that you can understand. Let's say we take the students example itself, where we are talking about, let's say, the roll number of the student, okay, and the name of the student, as well as the subject that they are enrolled in. Okay, now what you will see over here is that, let's say if I have 101, 102 and 103, econ, now can we look at this table and say that this is a table in one normal form? No, right? This is not in one normal form because we have a multi-valued attribute over here. So one normal form is the first thing that you need to ensure in your databases, that multi-valued attributes are not present. So how to solve this problem is that you put that into different rows. here. Now this was C++ for this. Now I will put another one with this and this. Now 102, 10. If let's say it would have been maths as well, then I would have done thrice. Okay, so that's what here it really means, right? This attribute for this has now been changed and made for atomic values. The information is still there, but now it is ensured that the data is in one normal form. Okay, so that's what pretty much the concept about one normal form is. Now let's move ahead and talk about second normal form. Okay, now for second normal form, the concept is that for a table to be in second normal form, it has to satisfy two conditions. The first is that the first step is done, which is the one normal form. So it's like I told you, a step-by-step process. In order to reach to the step 3, you have to make sure that the step 1 and the step 2 are done. Okay, so here for a table to be in second normal form, the first condition is that the table should be in first normal form, that we only have atomic values. And the second is that there should not be any partial dependency. Okay, now there we go. We actually introduced a very new term over here, right? That there should not be any partial dependency. But the thing is, to ensure that there should not be any partial dependency, we should first know what partial dependency is, right? Then only we can remove it. So let's derail a little bit for a minute and first talk about what partial dependency is. And for that, let's first talk about what dependency is, right? And we did touch upon this a little bit earlier in functional dependencies. So let's take an example of a student's table, okay, which has the column student ID, name, registration number, branch, and address. Okay. Now in this table, student ID is the primary key, very well, and will be unique as well for each and every row, correct? Student ID is the primary key and it can be used to uniquely identify each and every row, okay? And hence we can use student ID to fetch any row of the data from this table, okay? Even for a case, like I told you, right? 2 students in the class who have the same name Aman, right? They might have a same name, but they will never have the same student ID, right? So even for a case where student names are same, if we know the student ID, we can easily fetch the correct student name or the name that we use is record, okay? So here you can see that here 2 students have the same name, Econ, right? But never in their any situation will their student ID be same. Their student ID will always be different, okay? Hence we can say a primary key for a table is the column, okay? Or we also talked about composite keys, right? Primary key is a single attribute. Composite keys are a group of attributes, right? We know that primary key or a composite key can uniquely identify each record in the table. For this, we've already done a lot of discussion. So if you've not watched the video for keys, I would recommend you watch that, and this will become automatically and very easily clear to you. Now, I can ask from a branch name of a student with student ID 0 and I can get it, right? From a particular branch name, if I know the branch name and if I know the student ID, I can particularly get that student very easily, okay? Similarly, if I ask for the name of a student, right, who has a, let's say, student ID 10 or 11, I will get it, right? Because if I know student ID, using the student ID, I can get the name of the student. Using the student ID, I can get the branch of that student as well, right? So like I said, all I need is student ID and every other column is dependent on it, correct? In order to know the, let's say some student comes to me, right? And they say that they want to know their, let's say, branch. So I will first ask what their student ID is, because in my database, branch is dependent on student ID. If the moment I know student ID, I can immediately tell their name also, I can tell their branch also, right? Their registration number. So all these attributes, name, registration number, branch, address, all of them are dependent on student ID. Every other column is dependent on the primary key, student ID, right? And all the details can be fetched using the student ID. Now this is what is called dependency, or rather we call it functional dependency. You can either use the name dependency or you can use the name functional dependency. It's pretty much the same. So the idea is, okay, now you know what dependency is, but what is partial dependency over here, right? Now that we know what a dependency is, we are in a better state to actually understand what partial dependency is as well. For a simple table like student, a single column like student ID can uniquely identify all the records in a table. But this is actually not true all the time. So now we are going to extend our example to see if I add just one more column, right, to see if more than one column together also can act as a primary key. Okay, now let's create another table, subject. Okay, you can see the subject table over here. It has two attributes, subject ID and subject name. Okay, and where subject ID is definitely the primary key, correct? So this is two tables. First, second is the subject table, where we are just storing the subject ID and the subject name. Along with that, the previous table was student table, where we are storing the ID of the student, name, registration number, branch and address. Okay, so we have another table for subject, which will have subject ID and subject name fields, and subject ID is the primary key. So here, so far this is the primary key, and in this is the primary key, correct? Now that we have a students table with student information and another table subject for storing subject information. Okay, now let's create another table which is score, to actually store the marks that are scored by the students in the respective subjects. Okay, and we will also be saving the name of the teacher who actually teaches that subject along with the marks. So here the score ID is, right, that means it's just a score table and we are assigning IDs to it. This is the student ID, that means the student with the roll number 10, right, and the subject ID 1, which is Java, basically scored marks 70, and the subject is taught by the Java teacher. So I am introducing one more table so that you can, see all of them together. So this is what score ID is. We have student ID, subject ID, marks, and the teacher. Okay, now in the score table, right, we are saving the student ID, okay, to know which student marks are these, obviously, and subject ID to know for which subjects the marks are there for. Okay, now together the student ID and the subject ID plus they form a candidate key, correct? If I know the student ID and if I know the subject ID, right, then only I can uniquely identify a particular row. Can I say that? Because it could be like this, right? Student ID is 10, 10, 12, 13, right? And subject ID is, let's say, C++, science, maths, English. Okay, something like that. Now, if I just give the student ID, then that is not enough, right? Because a student can have opted for multiple subjects. So using a student ID alone, I cannot uniquely identify a student. Similarly, just using the subject ID also, I cannot uniquely identify a student, right? Because subjects can be same for multiple students. Only when I know the student ID and his associated subject, then only I can uniquely identify a row. So student ID plus subject ID, a association of that, right? A composite attribute over here, right? Not composite attribute, I would say a composite key over here basically forms the primary key. Correct? Now, it's easy for you to get confused, right? Like I just said, how can this be a combination of primary key? See, if I ask you to get the marks of student ID 10, can we get it from this table? No, right? If I ask you to tell the marks of student ID 10, you cannot tell me the answer. Why? Because there are multiple rows for student ID 10, correct? No, because we don't know for which subject we are looking for. And if I just give you the subject ID, you do not know which student we are asking for. Hence, we need subject ID plus student ID to uniquely identify any row. Okay? But the question is again, where is partial dependency? Okay. Now, if you actually look at the score table over here, okay, if you actually look at the score table over here, we have a column named teacher, correct? There is a column here which is teacher over here, which is only dependent on the subject, correct? Because teacher is related to the subject, okay? For Java, it's a Java teacher. For C++, it's a C++ teacher, right? Now, as we discussed that the primary key for this table is student ID plus subject ID, correct? But the student name depends on the subject, correct? Hence, the student ID has, hence the subject ID has nothing to do with student ID, correct? That is partial dependency, where an attribute in a table depends only on a part of primary key and not all the whole key. Let me give you an example over here, okay? Primary key is what? Student ID plus subject ID. Okay, that means a row is dependent on that. But the one of the column is teacher, correct? The teacher has no relation with student ID, correct? The teacher has just the relationship with subject ID, correct? Here, if you will see, teacher is a column which is dependent on the subject, okay? How come the name here teacher is Java teacher? Because of the subject ID, है ना? And not in relation with the student ID. It does not matter who the student is who is learning the concept. The teacher is dependent on the subject, right? C++ teacher is dependent because the subject ID is 2. Java teacher is because the subject ID is 1, correct? So if you see over here in this table, the teacher is only dependent on the subject and not the student, right? So this is the concept of partial dependency, where one of the attributes of a table is not fully dependent, okay? This is full dependency. If the teacher was dependent on the student and the subject ID also, then it was full dependency. But here the teacher is just dependent on one part of the primary key, then is the concept we known as partial dependency. Clear to everyone? That it may so happen over here that teacher as an attribute is irrelevant, is not dependent at all over here on student ID, whereas the primary key of the table is actually a composition of student ID as well as subject ID. But the teacher is only dependent on subject and not student. This is the case of partial dependency. where an attribute in a table is dependent only on a part of the primary key and not the whole entire primary key. Okay. Now then we'll talk about, once we know what primary key is, partial dependency is, we know that the second normal form says that you should not have partial dependency. Currently my database has partial dependency. So what we'll do is we'll try to get rid of it. Now there can be many solutions for this, but our objective is to remove the teacher's name from the score table. The idea is that the teacher's name should not be stored in the student's table. So the simplest solution that we have is to actually remove the column teacher from the score table and actually add it to the subject table. Okay, because teacher over here is not dependent on score but subject, it makes more sense to remove this from here and actually add it over here. Correct? This will lead to less redundant values also, because if 50 students, let's say, have the subject Java, 50 times Java will be here. But here it will be this, and it will be this. So only one time you will be scoring. Okay. So that is how you basically remove partial dependency. Here, although we can store teacher within the score table, but it doesn't make sense. It's not really fully related to the entire whole primary key. It makes more sense to keep it in the subject table. Hence, the subject table will have a new attribute now, which will be the teacher, and the teacher attribute will actually be removed from the score table. And now our score table is now in the second normal form with no partial dependencies. All right. This is what we have in second normal form. First, you need to ensure that the data is in first normal form, and then you have to remove any partial dependency if it exists. Okay. Now, this is what about this is. Let's quickly summarize what we talked about. First, we talked about the normalization concept and the different normal forms that we have. The first normal form says that the data should be atomic in nature. That means multi-valued attributes are not allowed and composite keys are not allowed, right? Composite attributes are not allowed. Composite attribute like address is not allowed, and for a multi-value attribute like phone number, which has multiple phone numbers for a single row, it's not allowed. You have to segregate into different rows. The second that we talked about is in second normal form, which says that for a particular table to be in second normal form, it should be in first normal form and it should not have any partial dependency. Then we talked about what is partial dependency. Partial dependency exists when for a composite primary key, any attribute in the table depends only on the part of the primary key and not the complete primary key. Let me write it down as well. Partial dependency exists, okay, when for a composite primary key, right? It exists when for a composite primary key, an attribute in the table depends only on a part of primary key and not the entire primary key. Okay. And the next thing was how to remove partial dependency. To remove partial dependency, we can divide the table, remove the attribute which is causing the partial dependency and move it to some other table where it fits well. Okay. So that is what the idea is, and that is what we all discussed. I hope this is clear to everyone. I tried to give multiple examples at multiple places in order for you to actually understand what is happening and to take a good idea on how the overall concept will work. Okay, now again, like I always recommend, try to take some examples on your own, try to define a small database, take a few examples, try to introduce and remove normalization as a concept, introduce first normal form, introduce second normal form, and it will actually help you to learn a lot. Okay, so thank you so much for taking a look at this video. I hope I was helpful in making this topic a little bit easier for you by taking all of these examples, and I'll definitely meet you in the next video now, where we will talk about the third, the BCNF, and the fourth normal form. So stay tuned, we have some exciting more concepts coming up as well. Thank you.